All right, thank you everyone, and welcome to my session, A Developer's Guide to Data Modeling with Document Databases. I am Adrienne Braganza-Taka. I'm a Senior Developer Advocate at MongoDB. So as we discuss document databases, I want you to think back on your experiences with document databases, whether that's working with one of them or considering one of them. And I want you to ask yourselves, how many times have you heard these types of one-liners or zingers? Document databases are schemaless. So because of this very single fact, we should just throw document databases at everything. Or field flexibility for all documents. We need this. It's a pain to have to change our schema. Anytime you need to add another field, we have to do this entire script change, migration. It's a pain in the ass every time we need to add a field, delete a field, change it very slightly. We want that field flexibility. Documents can be any shape. Alongside of that, the fact that we can have any kind of shape for our documents means we can iterate faster, we don't have to adhere to those strict schema rules, and we can continue to get on with our day in terms of development. While flexibility is great in theory, it's usually not great in reality, right? Once we start getting into the nitty-gritty, once we start actually going into our application development, we find that reality dictates that all data actually has some sort of structure. Data has all kinds of relationships, and no matter how much we want to say that that doesn't matter, there's always going to be a way we need to use our data in a structural and relationship-filled way. And so that's why we're all here today. I want to guide you on how to create a data model specifically for document databases. And there are about 3 goals here. One particular goal, but it's threefold. The first is I want to show you an approach on how to develop a data model for document databases. Then we're going to apply the approach that we've learned to an actual use case. In this case, we're going to use it on a casino floor application, specifically on slot machine analytics. And then finally, once we understand how, the next most important question is why? What exactly are we modeling for? Because those answers to those questions are going to shape how that data model turns out. If you come away from anything from this session, it's that it's possible and it's necessary to create a data model for document databases, because the data model that you design impacts your application performance. How many times have you gone on social media and you see all kinds of counter examples of saying, for example, MongoDB is the greatest, I had some staggering performance, I applied it and now everything is so much faster. And you scroll down a little bit further and it says, this is completely ruining everything. My performance is terrible. I don't know what is happening. What is wrong? It usually comes down to the data model. And so that is how important it is. That is why you need to structure it in the most accurate and proper way so that it affects your application positively. So we'll start with, how do we actually build this data model? Because most people are like, when you hear schemaless and flexibility and everything is shapeless, you're like, is that even possible? How do we even do a data model? It is. And the first phase in that is to make sense of your workload. So this first phase is gathering everything you know about your data, everything that you could possibly want to know about what is happening in your application, what kinds of queries are running, and you're going to get all kinds of inputs in this phase. So what are those inputs? The first of which are going to be your operations. What are the queries that are being run in your applications? And not just which queries, which ones are running the most often, which ones are the ones that are not being run at all. You also want to try to quantify how many times your queries and operations are being run. That way you can get a sense of how your application is truly running and what is actually most important in your application. The next part that can help with that are production logs and statistics. So as you're starting to list out and qualify and quantify all of those different queries, confirm that with your production logs and monitoring statistics. You may think to yourself, oh yeah, that is the most important one, but do you find any production logs to back that up? Maybe that's just an assumption that you have made that is not actually there. It's always very, very useful to be able to confirm these types of logs and queries. Next are current and predicted scenarios. So just as I mentioned, you think you know your application, you've been working on it for a while, you're in the weeds of it, and you say, this is usually the only things that could happen in this application, right? This is the best happy path that is always going to occur. It is never going to do this. It should never jump to this function. It should never go here. All of these things are also important to note, because the next time you iterate on your application, the next time you scale your application, the next time you change any line of code in your application, something could change with your data. So it's always good to list out both current and predicted scenarios of what could occur. And lastly, you would want to collaborate with a business domain expert. So as you are in the weeds of all of the developer details of the code and the application, what your data looks like, it's always good to also double check with your current and predicted scenarios what a business domain expert says. What is happening on the roadmap? What is your next big launch? What is happening in the next 3, 6, 9 months? Those types of insights can help you determine these particular pieces of information in these inputs. So when you take all of these inputs, you gather everything there is to possibly know about the data that is running within your application, you'll get out of this phase the operations that you are usually using, the queries that you are running and the ones that you're not, sizes of data, more accurate sizes, not just estimates, but sizes of the actual data that you're working with and expect to work with, indexes that you may be needing because of all the different operations and queries you have found in the first discovery phase, and all of the assumptions that are currently part of your app right now. So those are the outputs of that first phase. And we're going to use this continually in the rest of this methodology of building our data model. Now that we know everything there is to know about our data, the next phase is to map out and identify the relationships within that data. Because as reality dictates, all data has some sort of structure. So in this phase, there's about 2 parts to do when we map out and identify relationships. The first of which is to quantify and identify them, right? And very quick refresher, who here has used SQL? Raise your hand. Okay, that's a good majority. I would be surprised if nobody did. So this should be a refresher to you, right? We are pretty familiar with these relationships. There's one-to-one relationships, there's one-to-many relationships, and there's many-to-many relationships. But we found that when we started to scale, as we started getting into the thousands per second type of requests world, we found there's one more relationship that might be needed to be able to fully describe our data. And that's something called the 1-to-zillions relationship. So when one-to-many is not enough, or even many-to-many is not enough, we found that 1-to-zillions can sometimes be used to describe that type of data. And more specifically, we added a numeral notation to be able to describe that. So in this, you would have the minimum. What is the minimum amount of this particular entity that you are expecting? What is the most maximum amount that you're finding for this entity? And then a third portion, which is the likely amount. In this way, because zillions is so large, this is a better way for us to be able to understand these are the more likely parameters for this particular entity. So just keep that in mind as you start to think about the relationships in your data, as you're finding all the different entities and relationships within your data, that if it doesn't seem to fit in the one-to-one, one-to-many, many-to-many, maybe this applies. So after we have found all of the different entities, we start listing them out. We have all of the relationships that we believe are implemented or should be implemented. The next part that we want to figure out is, do we link or embed? And this is a really, really big part about working with document databases. But everyone here, most of you raised your hand and said, oh yeah, I know SQL. don't worry, if you're like, what is linking and embedding? I will go through them very, very quickly. What is linking? The first instinct in your gut is probably correct. We have a document here that holds some information about a casino. In this case, we're talking about the Cosmopolitan. And in order for us to link to some other information, we refer to it with some sort of unique identifier. Does this sound familiar? Foreign keys? Yeah. So in the very same concept, being able to refer to information that is stored on a different collection, that's essentially what linking is. We find some information that is separate, it is held in a separate collection, and we link to it. Embedding, on the other hand, is taking that information and just putting it in there, putting it in the document, putting it in that same document. We take the information or the characteristics or fields that we need and embed them in the same document. And out of that, once we have your relationships, once you have your entities, once you start finding all the different fields that are part of your entities, this is the next step that you would need to go through and iterate through. What is better? Should we actually embed all of these different pieces, or should we link these different pieces? Now, linking is better when we have large amounts of data. When memory is very important, we want to most likely link most of your pieces of data. Embedding, on the other hand, is better when you need some integrity. Let's say you need to delete data together. Embedding is probably a better bet for you to do. So using these types of scenarios, you'll decide what is better, embedding or linking. And as a generic overview of what you should keep in mind when deciding what to do, you would want to consider also these aspects. Depending on the relationship of your entities and depending on the relationship of what you find in this phase, you may consider, is it more likely for you to do one read? Is it more beneficial for your application to do one read? And is the data that you're dealing with a one-to-many type of relationship or a one-to-one relationship? In that case, you probably want to embed. But if you're on the other hand, you want smaller reads and you're okay with doing many reads, then maybe linking is something that you want to consider. So we've made sense of our workload. We found every piece of data that we possibly could on our data, our characteristics of our data. We've mapped out and identified what are the different relationships in that data, what are the entities that we are dealing with in our application. And now we come to the third phase, which is applying design patterns, which, as a caveat, you don't always need to do. So this is part of this approach, but this is not a prescriptive approach, meaning you don't do every single phase. You do it as needed, and you do it as you see fit. So yes, there are design patterns. What is a design pattern? It's a reusable solution to a common recurring problem. Just like there are many programming design patterns and code review patterns that you may use in your teams. It's, in this case, for data modeling, it's a data structuring model that solves many common document data model use cases. And so because of that very fact, again, it does not mean you have to apply it. And we'll get into why that may be in, very, very shortly. So when you apply these design patterns, let's first talk about what kinds of design patterns are available. I'll go through a few of them. There are way too many. You're going to be sick and tired of me if I went through all of them. But I will go through a few that we're going to probably apply to our use case. And so the first one that is pretty integral to most of the design patterns that we have is something called the polymorphic pattern. So you see here, the late, great Kobe Bryant, may he rest in peace, is a basketball player, right? And in this particular collection, we're holding information on athletes. And here we have Kobe Bryant, who played basketball, and we also have Serena Williams, who plays tennis. Now, polymorphic patterns are great when we have a variety of documents that have more similarities than differences in them and need to be kept in a single collection. So for example, this could be holding a bunch of athletes that are part of a sports betting application where you want to look at the different stats or different characteristics of athletes. You're going to have some similar fields like what the name is, what the sport is that they played, and maybe the career earnings that they have earned. But depending on what sport they have played, sometimes that warrants other fields. So in Kobe Bryant's case, he has the number of NBA championships he has won, and if he's in the Hall of Fame or not. Whereas Serena Williams has slightly different fields because she's played tennis. The fields in basketball don't apply to her, naturally. And what that also means is that because the shape of this document can change, because the shape does not have to be exactly the same. This means that if we were to change Serena's information a bit and say we wanted to store all of the different events that are part of tennis that she has participated in, this is possible. The polymorphic design pattern is the backbone of most of the other design patterns we'll see, namely because of the fact that we are allowed to have these different types of shapes of documents living within the same collection. The next pattern is something called the attribute pattern. You'll see here we have a document on a movie. You may have heard of it before. And we have some indexes on the different release dates of this movie. In this case, we're looking at what release dates were for the movie Star Wars. And because release dates have many different countries that may have had different release dates, in the initial design that we've stored them as an individual field in each document. But when we do this, you'll see that the needed indexes for this are one per individual field, one per country that we have decided to list. And that's not always the best case. Where we want to use the attribute pattern is when we have big documents with many similar fields, but the subset of fields that we want to sort on or query on are the ones that we want to find. And in this case, it's the release date. So the way to apply the attribute pattern in this case is to instead morph it into a releases array, because that is the part that we want to search on, the location, and because this is the only part that matters to us in the terms of what we're doing in our application, we can apply the attribute pattern in this way. Attribute is the location. And as you'll see, that means we also reduce the amount of indexes that we need when we apply this particular design pattern. The last pattern that we'll see is something called the document versioning pattern. So this one is something really great when you need to extend systems, when you need to keep track of historical data, and when you just are dealing with a lot of different versions of documents or a lot of different versions of entities. So the greatest example of this is insurance. And in this particular case, we have a current policy. Usually when you have insurance, you have the current one that stands, what applies to you at this very moment. And in our case, we have Bilbo Baggins, and the very, very first document that we have stored as his current policy is he only has the elven sword right now, so that's all he wants to insure. But something like this doesn't usually change very often, right? You usually keep the insurance policy that you have, and you only change it very infrequently. And that's a great use case for the document versioning pattern. So once Bilbo has acquired that ring, which is very rare, maybe that's when he wants to change his insurance policy. So in this case, to apply the pattern, we will now save a copy of that older policy, in this case where he only insured the elven sword, and then we will update the current policy to now show that he is insured for both the elven sword and the one ring. So in this case, this is great because every time you need to query or look somebody up for their insurance policy in this particular case, you will always have the most current version available because you can just look at the revision. And if you ever need to audit something, which is very common for something like a regulated industry like insurance or in banking or in finance, then you also have the historical data of all the revisions that have ever been made with the policy revision collection. So that's another way to be able to store this in a document data model form. And there are so many more. As you can see, we can go through a lot. I encourage you to look at a really great resource by Daniel Kupal and Ken Alger. They wrote a series of blog posts on all of the design patterns. But you'll see here that we've kind of summarized where you would usually see these design patterns and what use cases they are applied to. In this case, we talked about the polymorphic, the attribute, and the document versioning pattern. And all of these are pretty similar. They are pretty good. You'll see them in content management scenarios. You'll see them in real-time analytics or single view scenarios. And you'll see a lot of them in catalog use cases. So that's it, right? We're done. We've done it. Those are the 3 phases for our data model, and that is it. No. As you start to iterate your application, as you start to grow or change your application, you'll find that you'll come back to this methodology. As you see that there are performance issues that you're having, maybe you find that a bit of data that you need needs to change, you will usually go back and reapply these phases as needed. This data model is going to evolve just as your application evolves. So it's always a good reminder to remember that once you're done, and even if you've gone through all 3 phases, that's not the end of it. You come back to it. You can go through these phases again to continue optimizing the data model as your application evolves. So now let's apply this methodology, right? We now know what the 3 phases are, and we will go through a very, very convenient sample here. Who knows what this is? I don't know if you've seen it before. You may have walked through it. It's a casino, right? We're surrounded by it here. I actually had a friend come by, and this is his first time in the US. And I said, this is going to be your first sample of the US? He's like, there's a lot of casinos around here, Mom. I said, this is just Las Vegas. But anyway, in this particular application, and where we're going to apply our methodology, we're going to look at slot machines, specifically analyzing the different characteristics of slot machines. And I can guarantee you a lot of these casinos have something similar to an application like this. So with slot machines, as you've walked around, maybe you've lost all of your money already at one of them, you'll find that there's all kinds of different slot machines, right? There's Wheel of Fortune, there's Buffalo, there's some based on your favorite TV show or your favorite game, board game, there's all kinds. And with that kind of variety come a very, very wide variety of how those slot machines are configured. What are the win chance rates? What are the jackpots that are associated? You'll see sometimes there's a whole round of slot machines that are all going into a single big jackpot, and they're all tied, and all of them contribute. So more players continue to play there, and the longer that nobody wins, the bigger that jackpot gets. You have games that have multiple, or you have slot machines that have multiple games on there, where you have Jacks or Better, Texas Hold'em. So all of these different types of slot machines warrant different types of characteristics about the slot machine, and that's what we're going to tap into today. So first phase, make sense of our workload. We're not going to go too deep into it. We're going to go into what is most likely in this particular case. And so with this, we've found that these are the 5 most likely operations we're going to deal with in this application. The first row shows the total player game time, and that's going to be a write operation that we find. In this case, every time a player inserts that reward card for those good points, you will always be able to write how long they have stayed at a particular machine. Every time they insert, leave, go to a different slot machine, insert, leave, go to a different slot machine, we can capture that data. So that is going to exist as a write operation for this application. And next we have a bunch of read operations that we have found regarding our slot machine analytics application. So that's the win chance rate, the anomalies and win rates, and the top slot machines that have been played. Those are the 2nd, 3rd, and 4th rows respectively. And in these particular cases, again, win chance rates are varied. Part of it is because of the Nevada Gaming Control Board that sets the absolute maximum that can be set on these, also how much they're willing to screw you over with the chances that you have, and also how often the casino themselves want to change the win chance rate up to the allowed policy. Then there's also anomalies in win rates. So as they start to see, I don't know if you've noticed, every time I look at the news, there's like some other visitor who's visited Las Vegas for the first time and they won $1 million jackpot. And it's happening more frequently. And that's certainly something that most casinos are going to want to look into. Is there something really, really wrong here, or is it just plain luck? And the top slot machines played. So a lot of casinos, they take contracts from the biggest slot machine makers. There's Konami, there's IGT, there's Aristocrat. All of these are the makers of most of these slot machines. And usually they want to see which ones perform the best. So in this particular case, they can analyze which sets of slot machines are being played the most thanks to those particular analytics that are coming from those makers. And finally, the last operation we found is the jackpot increases. And this is going to be right. So I've described it earlier. There's a set of slot machines that usually all go into a single big jackpot. And the longer that players continue to play at the slot machines that are part of that jackpot, the longer that they don't win, the bigger the jackpot grows. And it continues to grow and grow and grow until someone finally wins that jackpot and then it resets. So these are the top operations that we have seen. These are the ones that we're going to focus on as we apply our data model right now. The next part is mapping out what are those relationships and what are the entities that we are going to be dealing with as part of this application. So again, we're not going to go too deep because this is going to take up all the time, but we are going to focus again on the most important ones. So out of the information we've collected in the first phase, we know we're going to deal with casinos. We know we're going to deal with slots. That's pretty much the largest and most important entity that we're going to deal with. We're going to deal with jackpots and memberships and players, games, bonuses. These are the entities that we know we're going to deal with. And on the same side, we know what kind of relationships we're going to expect with these entities. So for slots, for example, slots in casinos are usually going to be a one-to-one. And I say one-to-one because we're referring to the physical slot machine. There can only ever be that single slot machine with that particular serial number physically in a single casino. So that's why that is usually a one-to-one relationship. And the rest are there. I'm not going to read it for you, but most of them fall within the one-to-many relationships in terms of slots and bonuses, jackpots and slots, so on and so forth. And now we apply the design patterns, and don't be overwhelmed because it's like, bam, there's a data model right there. We will go through them. So as we've found these entities, as we've decided these are the best pieces of information to capture for our application, you'll find that these are just some fields that we know we're going to keep track of as part of our entities. So the first portion to take note here are, these are the entities we decided to embed. We decided to embed the bonuses within the slots because if for whatever reason we needed to remove the slot, we also don't really care about the bonus that applies with it anyways. So we want to keep that integrity in case we want to delete that document. The similar use cases come with players and memberships, for example, or their contact information. This is data that is meant to be deleted together, and so in this case, we decided to embed those pieces of information in those entities. Similarly, in jackpots, we have added the participating slots. So this is capturing that use case where all of these slot machines go funnel into that single jackpot. And we also have the casinos and the top slots we've decided to embed. The next design pattern that we see here is the document versioning pattern that we discussed, which was the Bilbo Baggins one, the insurance example. And in this case, we are deciding to keep revisions on the slot machines and revisions on the players, because usually players don't have their information change as often, but we also want to keep track of all of those pieces of information and only care about the current piece of information, the current contact information, the current membership information that they have. That's what we want to know about our players when we query them. Similarly to slots, as we start to configure them, we only ever want to know the current one. That would be a very terrible thing if we decided to change the win chance rate and we were querying the older version, which was less beneficial to the casino. We have the attribute pattern also in place here So for the slot machines, we usually want to look at them via the different type of bonus structures that are applied. When they categorize the slot machines at most of these casinos, they all fall within that same range. And specifically on the casino floor, there are different win chance rates and different bonuses depending on where the slot machine is located. So if you've ever noticed the slot machines that are closest to the exits, those usually have a very low bonus structure. They have a lower win chance rate, and that's on purpose because as people come in, as they walk in and they're just walking the strip and they've seen a slot machine for the first time, that might get a lot of traffic and they might try once or twice, but that's pretty much it. They want you to come in. They want you to get lost in the labyrinth. They want you to stay and not know what day it is, what time it is. They want you to move into the middle of the floor. And so those slot machines, those are the ones that might have different bonus structures. And we've captured that in this way via the attribute pattern. And finally, we have the polymorphic pattern, which if you think about it, it's going to apply to most use cases if you use a document database. So in this case, this particular slot machine, we've kept information, very similar information. We have the manufacturer, we have the serial number, we have the win chance rate, and in this case, this is a very default slot machine. What are the bonuses that are applied to this particular slot machine? But polymorphic pattern states that we can also have an object like this. So let's say we have a different type of slot machine that has different types of bonuses. A Wheel of Fortune slot machine is going to have a different type of document to one of your 5-line type of slot machine, because a Wheel of Fortune has that spinning wheel at the top, right? And that bonus is very characteristic of that particular slot machine. You don't see that on any other slot machine, or it's very similar to that category of slot machine. But all of that is to say, the document that captures what this slot machine looks like will have a different set of fields. And in this case, the game bonuses are what's different in this document. And again, polymorphic states that we can have a document that looks like this. I don't know if you've seen, but a lot of the slot machines out there, they're all turning digital. Even the wheels are digital. They're not actual mechanical wheels anymore. They just look like them. And so as more and more slot machines are replaced, you'll find that a lot of the actual original ones, the mechanical ones, are being phased out. And so for those slot machines, we may capture their information in this way. In this case, we have all of the similar ones, right? The manufacturer, the serial number, all that. But for something that's going to be phased out, we have probably maintenance logs on that particular slot machine. We have a potential decommission date for when that old thing is finally leaving the casino floor. And so this is just to say that depending on the type of slot machine that we are keeping track of, the polymorphic data design pattern is there to back us up to be able to capture all that different type of information based on the slot machine. And so that is how we have applied this. And this is the first iteration of applying this methodology to our example. We will continue to go through these steps as we needed to apply them. If we were experiencing performance issues, for example, we might need to go through them again and maybe apply a few more design patterns to our data model. If we found that there's actually different pieces of information we needed to keep, we would go through phases 1 and 2 and evolve our data model to accommodate those changes. But in essence, this is how we would apply this methodology to create a data model using a document database. So now we come to what I think is actually the more important question before we even start all of these phases is, what do we actually model for? Why are we doing this approach? Why are we applying these 3 phases? Why are we doing it iteratively? And when you answer that question, I find that the answers that you have are going to come much more naturally when you do each of these phases. It's usually going to fall between these 2 answers when you decide what you want to model for. On the one end, there's simplicity. On the other end, there's performance. Usually, when you are deciding between the 2, these are the things that you want to look for, with the big caveat to always err on the side of simplicity. So if you're a smaller app, if your team is on the smaller side, or if it's just you working on a particular data model, if you have shared resources or hosted resources that you are using, and your expected scale is not that large, then go on the simple side. Don't make it harder for yourself. Part of a good data model is one that is easy to understand. Part of a good data model is one that you know how to get back to and refactor later on. If you are finding that you're on the other end of the spectrum and you are on a larger project, you have a distributed application, you have a larger team, you're on a global scale, you're in multiple regions, and you're in that scale where you're dealing with thousands of requests per second, then yes, performance is something you can start to consider. Performance is something that you can start to say, this is what we should be modeling for. We're done with being simple. So for the most part, if you've found that you find yourself on the simplicity side, if you say, this is what we need to model for, out of the 3 phases that you need to go through in informing your data model, you'll find that focusing on the most frequent operation, embedding everything, embed all the things, and using only one pattern, if it even makes sense, maybe not even using any patterns at all, this is the way that you can focus on simplicity. Focusing on creating the simplest data model that you can create. This is great base to start on and is usually what you need right away and can last you pretty long. If you continue to focus on simplicity, you'll find that as you evolve your application, you only need to make a few more tweaks. Maybe you add another design pattern, maybe you start to look at the next 2 most important operations, but for the most part, it's going to stay fairly simple. If you find that you start having performance issues, on the other hand, if you find that you need to start modeling for performance, then you go to the other end. You need to look at every single operation. You want to quantify each one. You want to qualify each one. You want to embed and link as necessary, with probably a lot more linking if you're in the 1 to zillions type of relationship. And if you have a lot of performance issues, you want to apply as many design patterns as possible and as needed. And as you continue to apply them and you find that there are some improvements, you may want to go through them again and see, are there different design patterns that may actually increase your performance? And for those that want both, because who doesn't want everything in life? We want simplicity and performance. Similarly, you're going to fall right in the middle, right? Maybe you do most operations. You embed and link as necessary. And again, you use maybe a few patterns. But the biggest point is only applying them when performance issues occur. The more that you continue to do this, and the more that you iterate your data model as you iterate through your application, you'll find that the data model that you have is the one that you'll be most happy with. Thank you so much. Salamat. That means thank you in Tagalog. I will be here for any questions. Thank you for taking the time today.